zeros, relative extrema, and press. So we're going to see what's happening with our graphs. Now the first thing, if you haven't grabbed a graphing calculator, you do need to get one quietly. But that's going to be very necessary, and in fact, I need to get my graphing calculator up and running, which is right here. We can take yours Thursday after school if you want to do that. And we're actually going to be using that to help us. So here's our first question. We're going to determine the domain and range of f of x equals 3 minus x squared. And we're going to write our answer in interval notation. So the first thing you probably want to do is to write down part of that question into your notebook. And then the second part is we're going to type that into our y equals 2 screen on our calculator. I think graphing actually helps when I'm looking at something. So I'm going to go ahead and graph it. And the way I do on these calculators is I click the y equals, clear anything that's there, and I'm going to write 3 minus x. And this time I can actually just hit the square, it'll pop right up there. And hit graph. And there's my beautiful, beautiful graph. Now yours is probably not blue, right? I've got a color graphing calculator, by the way. Talk to CI, they hook me up, they help me out a little bit. Now, domain. So the first thing we're talking about is domain. So I'll write domain. When you're talking about domain, what are you talking about? You talking about the Chesterton Mallory? The x's. We're looking at the x's, right? Now, as I'm looking at my x's, do my x's go continuously this way? Yeah. Do they go continuously this way? Yeah. Now, I know that if I'm looking at this graph, it looks like, oh, well, the x's stop here. But if I continue my graph, I can actually keep going, right? That means I'm starting at negative infinity and going to positive infinity. But it wants us to write this in interval notation. Well, here's a question. Can you ever actually get to infinity? No. So when you actually don't want to include a number, we use a rounded parenthesis. And we're going from negative infinity to positive infinity. So the parenthesis means that number is not included. If we use a bracket, it means the number is included. Which you'll see that here in just a second when we talk about range. Now range is what letter? What letter corresponds to this? The y. Let's go back, let's look at our graph. Look at the y value. I actually see it starting y value. What y value does this start at? Positive what? Positive 3? You guys agree? Yeah. In fact, can you get to exactly 3 on the y-axis? Yeah. So that means it's included. Now, it goes from 3 to what number? To where? To negative infinity. But I don't want to say 3 to negative infinity. I actually want to start with the negative. Since I can't ever get down to negative infinity for real, I put a parenthesis. And it's going the whole way up to 3. And 3 is included, so I'm going to use a bracket symbol to say, hey, this is included, it works. Sparta. Yes. Yes. How do you feel with that? Okay. All right. So now we know about domain and range. We're going to use the vertical line test to determine if it's a function. So go ahead and graph it. And let's see if it's a function. So I want to graph this. I'm going to take my calculator, and there's a couple key things I need to worry about when graphing this. The first key thing is I need to put parentheses around the -1/4. If I forget to do that, then the whole problem will be messed up. The other thing is that negative sign needs to be inside the parentheses. So now I'll type the x squared and hit graph. So my lovely graph looks like this. Kind of a fat U shape going down. Somehow it looks out. Anytime you have fractions, be careful with that though, because sometimes it doesn't work that way. So I try to get you in that habit of using those parentheses now so you don't have that mistake. Alright. So I'm going to use the vertical line test, and we talked about that yesterday, correct? Now, this is my vertical line. This is my pen. And all I do is I take my pen and I go across it like so. Does it pass the vertical line test? Yeah. So is this a function? All right. That was a simple page, wasn't it? Okay. So now let's find the zeros. Oh, zeros. We've got a couple different ways to find zeros. No, that, remember, would find my y-intercept if I plug in 0 for x. Trying to find a zero. What's another name for a zero? What? Not my origin. That's 0, 0. They're my x-intercepts. So another name for zeros are x-intercepts or roots. Now the reason I give you both, or actually all three of those words, it all depends on what calculator you're using, to what word they use. So I don't want you to be going to another math teacher and using their calculators and being like, the word I'm looking for is not on here. So any of those three words match up with what we're finding. Well, what way could I do this without a calculator? Whitney. Do what? Okay, which is what? Not FOIL. Another word with that. The opposite. Factor. So we're going to factor this. So, welcome back to Algebra 2. And we learned factoring, and we called it, we look first for what when you're factoring? GCF. That's the first thing you should look for. You see a GCF. Okay. Second thing you look for is A equals 1. And remember, A is the number in front of the x squared. Does it equal 1? No. So then we use our famous Bednar method. In case you forgot the Bednar method, we're going to walk through it right now. So 2x squared plus 13x minus 24. In order to do the Bednar method, you cross off the 2, and you multiply the last number by 2. So I get x squared plus 13x minus 48. And then we factor that. We have to ask ourselves, what times what is negative 48 but adds the 13? What times what is 48? 16 and 3. 16 and 3 works. Okay, so 16 and 3. What kind of 16 do you need? Positive. And here's how to know. Whatever sign is here, the bigger number gets that sign. Okay, so if this was a minus sign, the bigger number would get the minus sign. Now, since you multiplied by 2, now we have to divide by 2. Which means I'm going to divide the 16 by 2 and I'm going to divide the 3 by 2. 16 divided by 2 is 8. And here, since I can't actually divide those, I just take the 2 and move it to the front. So I get 2x minus 3. Well, we don't like to have a fraction in there, or a decimal, or anything like that. So we like to write it that way. Now we set them equal to what? to 0. So x equals -8. Now, Nathan, you actually said, could I write x minus 1.5? And I said, no, we don't really like to do that. But you can look back up here to help us with the answer so you don't have to show any work. What's the opposite sign of -3/2? Positive 3/2. So there's my other answer. That saves you from actually setting it equal to 0, but there are times you want to write it out in the parentheses instead. No, go ahead.
Where did you get the 2? If you ever do it.
Since I multiplied this by 2. Whatever number I crossed off there and multiplied here, I then have to divide by that number also. Okay? Good question. Very good question. Now, luckily you have a calculator in front of you. How nice is that? Calculator right now in front of you. So let's check it. How can I check this answer using the calculator? Plug them in? Okay, I could plug them in. But guess what? There's an easier way. How about let's graph it? Graph that equation. 2x squared plus 13x minus 24. So I'm going to graph that. 2x squared plus 13x minus 24. So it looks like it's at -8 and about 3/2, right? Hey, look, that's what I had. Now, we don't know it's exactly 3/2 unless we do this work. That's why you have to show that work. But if it's a quiz or a test day and you want to just check your answers, look how quick that was to check right in the calculator and say, here it is. Here's my work, Missy, but I know I've got it right from the calculator. You must show me work on the quiz. No. You'll have to show me work on the quiz. All right. Let me move this for us so we can actually see the whole number here. There we go. There we go. I can move that there. So now what we're going to do, we're actually going to use the graphic calculator complete to figure out increasing and decreasing behavior in interval notation. So interval notation is what you started with. Remember with the parentheses and the brackets? Brackets are if it's included. Parentheses means it's not included. So after you copy down that problem, go ahead and graph it. So I'm going to go ahead and graph this. It's x cubed plus 3x squared minus 1. Now, this is where you may say, all right, I don't really like this calculator because it's new to you. Because when you do x caret 3, after you do that, you must hit the over key. Twice. That way it knows that you're no longer being an exponent. Okay, so the problem was x cubed. What was the rest of it? Plus 3x squared minus 1. All right. So I'm going to go ahead and graph it. There it goes. Oh, look how pretty. All right. So what's the highest value right here? What x value makes it the highest? I'm sorry, what x value makes it the highest? This part right in here. Not 2, you're close. -2. Okay, -2. Now, so notice that this graph actually increases from over here the whole way to x equals -2. Typed in something wrong maybe. Okay, but it should be at -2. Okay. Are you looking at the y number or are you looking at the x number? When we're talking about increasing and decreasing, we're talking about x numbers only. Okay? So if I'm looking at the x value right here,
Oh, okay,
I'm looking at
gotcha.
this line.
Yeah.
Okay. Now what x value makes this the smallest? What x value? 0, right? Okay, so when you're talking about increasing and decreasing intervals, you're only going to look at the x value. That may be something you want to write down. When looking at increasing and decreasing intervals, you're only looking at x values. X values. That's it. The y values we're not looking at all. So we have to go across on the x-axis itself. So I'm going to look right here. As I'm looking on the x, where am I starting on the x? The whole way over at what number? At what? Close. Infinity's over here. Negative infinity. I'm going from negative infinity to what number? Negative infinity to negative 2. So negative infinity to negative 2. Now, notice I put a parenthesis around negative infinity. Why? Okay, it's not included. Now, how about negative 2? Here I go across, I'm at negative 2. Am I still increasing at negative 2? Am I still decreasing maybe at negative 2? Am I doing anything? So I'm not actually including negative 2, am I? I go the whole way up to negative 2, but don't include it. Because at negative 2, you're just stuck. And for that interval, you are increasing. See if you can write the next 2 intervals then. I'll give you a hint. After increasing, the next interval should say decreasing. All right, so I had you guys trying to write the next 2. Now remember, I look at the highest point, but I'm not looking at the y value. I'm looking at what x value makes that the highest, which we already talked about was negative 2, right? And if I go over, it actually starts turning at what number? 0 for my x number. So from negative 2 to 0, it is decreasing. Notice I repeated the negative 2. So what number do you think I need to repeat now? I need to repeat the 0, and now it goes from 0 to infinity, and for that it is increasing. Okay. So one key thing to note here, when you're talking about increasing and decreasing, you'll always use parentheses. When you're talking about increasing and decreasing, you'll always be using parentheses, at least in this class. All right. Good. Move that back, pin it back there, fix that, clear and go. All right. So now what we're going to do is use the graphing calculator to help us to find the relative maximum. So in that last problem, we looked and figured out what it was, right? Oh, my maximum is at x equals negative 2, approximately on the last problem. Well, what if it's a decimal? What? Well, what if it was like 2.387? Would you be able to come up with that just looking at it? No. You wouldn't be able to come up with a pretty close approximation, but your calculator will. We're going to show you how to use your calculator right now to approximate it. First thing you have to do, guess what is? Graph it. So go ahead and graph that in your calculator. All right, so I'm going to go ahead and graph this. Negative 4x squared minus 7x plus 3. So y equals, clear that out, negative 4x squared minus 7x plus 3. Is that correct? I actually don't, since it's not a fraction, I don't have to have the parentheses. But you can put them there, that's fine. picture, and it looks like the highest points at what? 1 comma 1, 2, 3, 4, 5, 6 maybe? 1, 6. It looks like that would be the relative max. A relative max, all that means is a maximum in an interval. So if I said find the relative max from -10 to 10, what's the highest point you see on the graph from those x values? That's all you have to be able to tell me. Well, I want to figure out, is that the exact value? And here's how we do that. We go to second calc. Now, we just talked about this. Are we finding the max or the min? Okay, so go down to where it says max. And actually now they say maximum. All right. Is yours a little easier to see now compared to last year? Oh, it is. Okay, so notice yours says left bound, right? That means you need to be on the left side of that bump. So I'm going to hit the left key until that little blinky cursor is somewhere over on the left side. It doesn't have to be close to my left side, it just has to be somewhere on the left side of the highest point. Everybody about there? Well, when you're there, hit enter. See, mine actually helps. It draws a line in now, which I think is pretty cool. But now what's your set? Right bound. That means get to the right side of the highest point. That means I need to move to the right. All right. How about there? Okay, hit enter. Now it says guess. I'll be very honest, I don't guess. I just hit enter. And it does some calculus to work it all out, and it actually comes up with negative 0.875, comma 6.0625. So it's close to what we had come up with, right? But not exact. Now, why would it be important to come up with an almost exact answer? Why can't I just round it? Okay, not the max. Here's a real life situation. I'm building a bridge. You know, it looks like it's about 50 feet, when in fact it's 51. Does that make a big difference? Yeah, your bridge no longer fits, does it? You're only off by a foot, not that big of a deal, but 1 foot now means that nobody can go over your bridge. So it's important to find an exact answer sometimes. So luckily, the calculator can help us with that. Yes, and we'll actually write it down that way, where we'll write negative 0.875. We're going to round it slightly. And I'm only rounding it because now it has 2 zeros with it. That's close enough now. And then 6.0625. 6.0625. That's not too much to write. Enough the answer there. That is the answer. All right, so now let's find the average rate of change from -1 to 3. We've got 2 slides left. We're only going to do one of them, from -1 to 3. What do you think -1 and 3 are? Other than numbers. No, it actually doesn't in this case. Okay. So where would you said a letter with that. You said x's. Those are going to be my x numbers right there. Yeah. Well, it's not actually where the parabola hits the x-axis. So I know x equals -1 I know x equals 3. So I know -1 and I know 3. How would I find the y value? Plug it in, right? So watch this. This is my way of making it quick. If you are a girl, I want you to plug in -1. You are a boy, I'd like you to plug in 3. I just cut the work in half. That's all I did. Now, when you're plugging it in, you're plugging it into this function up here, the f of x function. When you're plugging it in, that's where you're plugging it in. And then what you get is the y. Let's get 3 again. Girl. So it says we want to find the average rate of change. You'll hear those words quite a bit. Not only in this class, but you're going to hear them if you take physics or if you take calculus. But does this formula look familiar? Kinda? F of x. It's the same thing as what other letter? So you know what I'm going to do? I'm going to put y2. Instead of this, I'm going to put... What formula is that? Yeah, that's slope. Find the slope between those 2 points. So when it says find the average rate of change, all you're doing is finding slope. So here I got slope is 0. Make sense? If I graphed it, let's just pretend that's the graph. All that's telling me is these 2 points are exactly the same level. So the slope's 0. Now I could do that with another pair, but do you guys feel comfortable doing it with just one pair? And then when you do the essential work tonight, look at your nose, because that's how to do it. One more problem. This is it. We're going to determine if this is even, odd, or neither. Now I know I said what about symmetry also, but you can look back for your symmetry stuff if you'd like, but let's talk about even and odd. So all we're going to do right now is to talk about even and odd. So I'm going to check even first. If I'm checking even, I'm going to plug in -x to all of the x's. So 5 minus 3 times -x. What's that become? Minus 3 times -x. What's going to happen? It's going to become what? Yeah, exactly, Leanne. It's going to be plus 3x. So if I'm checking even, I put in -x and I see, do I get the original function back? Did I get it back? Okay, it's not even. It is not even. It's that quick. Okay, I'm going to check odd. Okay, now when I check odd, I do the exact same thing. Look, I plug in -x. Do I need to redo that whole problem? Okay. So I'm just going to recopy that down. 5 plus 3x. And I'm checking, does it equal negative f of x? Okay. That means the opposite. So everywhere you see a positive number, you make it negative. Everywhere you see a negative number, you make it positive. So that becomes -5 plus 3x. I switched the signs of everything. That's all I did for odd. I switched the signs. No, what's the opposite of minus 3x? I'm using the original function and changing all the signs. Are they the same? No. So it's not odd. So guess what it is? It is neither or neither. Neither, neither, whatever you'd like to call it. That's the answer. Does that make sense how I did that?
Where did you get the again?
How'd I get the what?
Oh, never mind.
Oh, good. By the way, if you start with even, half your work is done for odd. Isn't that nice? They help each other. Any questions?
I don't know.
Okay, where are you last time? Do you see how I got this first part?
No.
Okay, so what I did was I put a negative x into all of my x's. Well, there's only one x. And I simplified it.
Okay.
And then what I had to do is check, does that equal the original function?
Yeah, okay.
Okay, no. So in the second one, it says put in negative x. Well, you already did it. And now it says negative f of x. We switch the signs. Are they the same? So then it's neither.
Yeah.
Does that make sense now?
Yeah.
All right, here's your essential work.